Welcome everyone to today's AMA featuring Professor Ronghui Gu, co-founder of Certik, and Stuart Popejoy, founder and president of Kadena. My name is Miguel and I am the marketing manager for Kadena. I want to thank everyone for joining us for our second live AMA. We want to especially thank those of you who submitted questions as well. To get things started, I want to go over the format. For those of you listening, please ask your questions in the Ask Kadena thread. And if you see a question you like, just add a reaction to the question in the chat. The questions with the most reactions will get priority. Just be aware some of the questions might be answered by the Kadena team in chat. So let's start with some quick intros and a little background for people who may not be familiar with either of you. We'll start with our guest, Professor.
Okay, thanks. So hello everyone. So I'm Ronghui Gu. I'm now an assistant professor in the computer science department at Columbia University. And I'm also the co-founder of Certik, a company that focus on the formal verification of blockchain ecosystems. So my research is mainly focused on the formal verification, especially the verification of system software. Yeah, so I believe that's it.
Great, thanks, Professor. Stuart, Stuart, let's go for it. Please show me your introduction.
Okay, hey everybody. Thanks for joining our AMA. My name is Stuart Popejoy. I'm the founder of Kadena, along with Will Martino. We founded Kadena after working at the JP Morgan blockchain group for about 2 years, and that was in 2016. I'm the author of the Pact smart contract language, which features formal verification features inside of the code itself. And I'm very looking forward to answering your questions.
Great, thanks, Stuart. So let's start with a question that'll bring everyone to the same page. What is formal verification? Explain it to everyone in the most simplest terms, and feel free to give examples or use cases. So let's start with Professor.
Okay, so I will try. By formal verification, we basically mean to use mathematical ways to prove that the code indeed satisfies some specification. So you need to have a code, right? Also, you need to have a specification which specifies the designer's intention. And then formal verification is simply to try to prove that these two models, the model of the code and the model of the specifications, are somewhat equivalent. So that is my understanding of formal verification.
Great, thanks, Professor. Stuart, do you have anything to add?
Yeah, I mean, I think the other thing to realize about formal verification that a lot of developers may not realize is that, or I should say that a lot of non-developers do not realize is that really computer engineering, software engineering is in the dark ages with respect to this technology, in the sense that the vast majority of software is tested using unit tests and occasionally small amounts of static verification. And it really means that we don't use the computer to test our code. We rely on developers to test their own code, and then maybe rely on humans to run through scripts. So formal verification, when you zoom all the way out, is actually doing what probably the rest of the world thinks we're doing all along, which is using the computer to test our code, as opposed and using the fact that the computer can, amass a much larger picture of the possible states that your program can be in. In the case of formal verification, it can put a total picture of all the states your program can be in and find bugs for you. And it seems it's something that's been known about and researched for decades, but your average programmer doesn't ever really get the chance to take advantage of this incredible power. And that's one of the things that we've really tried to do with Pact, is to give these tools to the smart contract developer, so that right as soon as they write a function, they can write the model for that function and have that be tested by the formal verification system in Pact.
Yeah, it's impressive to just see these programs being mathematically proven. And it's amazing to see that more systems are just implementing these functions. So our first question, digging right into it, comes from the Twitter sphere, and it's what is the difference between formal verification at the smart contract language level versus formal verification on the VM level, virtual machine? So
Yep.
let's start with Stuart.
Depending on how you look at it, there's different answers to that question, but I would argue that there's no difference because we have to be clear what we mean by VM. If we're talking about blockchain, that phrase generally means the EVM, which is the smart contract engine. So application code is executed in Ethereum using the EVM. So if formal verification operates on the VM, that is very similar to where Pact's formal verification, it would be operating on the code that would be executing in the blockchain. Now, the reason why that might be confusing is because in Ethereum, generally speaking, nobody codes in EVM. Everybody codes in some surface language, which is compiled to the EVM. As a result, it's so, and Solidity obviously being the main language that people use, and Solidity is not the whole of the language of Solidity is not possible to formally verify. However, you can use a subset of Solidity called Solidity Star to do so and interact with some of the tools that are available for the EVM. But it adds a certain amount of complexity. Whereas with Pact, the language that you write in is the interpreted language that is used by the blockchain. So when you are performing formal verification on a Pact contract, you are actually testing the code that will run in the blockchain.
Yeah, complexity does play a big part on how we could do a better job of just getting more companies and more projects to implement formal verification. Professor, do you have anything to add on the difference between smart contract language level versus
Sure.
virtual machine?
Sure. So, so first of all, formal verification is a technique that, in most cases, is independent of the language, the program language, and also your target. So it's a pretty general technique, pretty general term. But the verification of smart contracts and the verification of VM, I would say there are still many differences. So first of all, smart contracts are much easier to verify than VM. The main reason is the execution model of smart contracts in most cases is very simple. Let's say is, for example, the smart contracts on Ethereum will always be executed in the sequential model. You don't need to worry about concurrency. You don't need to worry about the network delay. You don't need to worry about the kind of like the distributed system environment. Those are all abstract away. And also, you don't need to worry about non-termination, right? So although Ethereum is claimed to be Turing complete, the EVM is claimed to be Turing complete, but actually it's not, because you need to guess. All the smart contracts will eventually return, at least after you burning out all the gas. You can see that the execution model of smart contracts are much easier than the VM. But when you verify VM, well, you have to deal with all the kind of like the distributed execution environment, and hopefully it will run forever, something like that. So it's a little bit harder. This is first different. Second different, I would say that well, the verification of VM is kind of like you do it once and for all. Let's say if you build a verified VM and you prove that it's always correct, it always satisfies the specification, and then your job is done, right? You know that the execution of smart contracts will always be the same with the expectation. But for smart contract verification, let's say
there's space in the middle.
Oh, sorry. Oh, well,
No, you're good. You're good.
Yeah, I'll keep going. So for the verification of smart contracts, so first of all, it depends on the correctness of the underlying VM. Meaning what? Even if your smart contract is written correctly, if there are some loopholes in the VM, well, others can still attack your smart contracts using the bugs in the VM. So smart contract verification relies on the correctness of VM. Second, for smart contract verification, well, different smart contracts have to verify. You have to verify all these smart contracts, right? So kind of like that's also a pain point.
Yeah, some good takes there, Professor. The EVM is not Turing complete. Smart contracts not deterministic. So here's some really good points there. Let's looking into our next question. Who are the key groups that should care about formal verification? Why should these people care about formal verification? So we'll continue, Professor. I'll let you take this one.
Oh, you mean group is group of what? Group of people or group of developers?
Yeah, just group of individuals and developers in general.
Oh, yes. So to be honest, I would say, as Stuart said that, well, I would say every developers and every non-developer should care about formal verification nowadays because system software has already controlled our life, right? So, well, those system software runs on your car may take control of your car and runs on your laptop and may leak your private information, and those system software runs on the cloud may also leak the private data of your VM and so on. And also we are in the crypto world, and here we believe that code is law, so we also need to trust the code. But we all know that code has bugs, implementation has bugs. It's not that trustworthy. So I would say nowadays everyone should care about the correctness of the system software, the security of the system software, and then you should definitely should care about the formal verification, because as one of the NSF report in 2016, that well, formal verification or formal methods are still the only knowing way to guarantee the security and privacy of computer systems. So I would say everyone, right, should care about formal verification.
Yeah, so you make some good points, Professor. Again, code is law, and there's bugs. It's not
Yes.
trustworthy.
Yep.
Stuart, would you have anything to add?
Mainly just that I think in the context of smart contracts, formal verification really comes to the fore because we're, especially in public blockchain, we're directly dealing with, programs that are directly handling money. So, privacy is obviously very important. A lot of the things that we deal with in the rest of the world, and of course, safety systems that are tasked with, guaranteeing our physical safety, those actually are where a lot of formal verification techniques have been employed, or at least, extensive static analysis or other things like that. But what we face with smart contracts, especially with Ethereum, is contracts that are guarding or managing very large amounts of money that bugs directly result in theft. So I think I think there's two reasons why smart contract developers should be focused on this. First, the money involved, but second, as the professor points out, it's a environment that really should be easy to verify. And we can look back to Bitcoin, which is trivially easy to verify because the surface area of the language is so small. This is something that one of the reasons why Pact is a very easy language to use these techniques on is because it embraces some of the design principles of Bitcoin script, namely Turing and completeness. So the fact that you have a substrate or a runtime that is much easier to use these tools with really should mean that every contract that's rolling out to the blockchain should be using formal verification to guarantee its safety. However, that's not the case, and that's something that I think we both seek to change.
Yeah, I agree with the both of you, and it sounds like just the biggest variable in both implications is just human error, and which formal verification hopefully solves in a more general sense.
It's not just
Just
human error, because the problem with relying on developers to write perfect, you need to the thing that people need to understand is that you can't expect developers to be perfect. And by perfect, we mean more than just human error. We mean think of every single possible thing that can go wrong. That's just not a human capability, but that is something that we have in our sights for being able to do with smart contracts. So smart contracts that are not using these tools are really putting their users at risk.
Yeah, agreed. Completely agree. So, just looking forward. So this is going back to Stuart. Kadena's focus is often on enterprise adoption. Can you give us an example where an enterprise might flat out refuse to build on blockchain due to security issues? Could formal verification have changed that decision?
I think you see a lot of enterprises refusing to develop on blockchain because of security issues. Now, some aren't going to be at the smart contract level. So if you are concerned about the fact that, core devs of some public blockchain can change the semantics of the blockchain without consulting some of the, kind of core users, which might include a large corporation, that's something that is it can be a security issue, it can be a governance issue. There's a lot of reasons in public blockchain that make it that can make it uncomfortable, especially for enterprise level companies. Now, when it comes to using permissioned blockchains and private blockchains, I think there's a much larger comfort level because there's at least a concept of the participants, the people who are participating in the network being known in advance and being agreed upon in advance. And at that point, I would argue that the security of the system, I've kind of seen the opposite, where I think people aren't concerned enough about the security of some of these private blockchain systems, as we've seen with things like IBM Fabric or with R3 Corda. You have smart contract logic being written in general purpose languages like Java. And it's very, very difficult to verify behavior in something like the JVM, simply because it's so unconstrained. And there's so, as we've discussed earlier, the fact that you're dealing with a much more chaotic set of possible states. So we have a tendency to think that enterprises are going to be more responsible, but the fact of the matter is they're huge companies and they're not always paying attention to every little thing they're doing. And in the case of blockchain, a lot of them are just trying to figure out their blockchain strategy, and as they move towards it, I don't think they may not be paying enough attention to things like formal verification.
Right. Professor, so Stuart brings up the point of different programming languages and just JVM, for example, it's difficult because they're not constrained.
Mm.
Do you agree? Has Certik looked into formally verifying systems where the same thing happens?
Yes, I totally agree with Stuart that as I also mentioned that different applications, different program languages, they have different models. Some models are easier to verify. Some models are harder to verify, harder to prove. So with more flexibility, definitely means that the verification will be more difficult. And so Certik, so we have built a verification engine for JavaScript. You can imagine there are many kind of not well restricted features in JavaScript. So its verification is much harder than Solidity actually, and so on. But I agree with Stuart, and also the design of Pact that some features, some flexibilities are harmful, and we should avoid in the design of the programming language level. Yes, that's it.
Yeah, for sure. I mean, flexibility is definitely harmful, and just being able to manipulate a language and just programming too many things is definitely affects just the capability and the increases the odds of just errors in general. So, Professor, this is from everybody, a good amount of people in our Discord, and they want to ask you what prevents every project from verifying their code with Certik?
Okay. So what prevents every project to use Certik to do formal verification, right?
Yes.
Well, I think I can even extend the question a little bit, as well. Formal verification has been a decades-long concept, right? As mentioned by Stuart, it dates back to 1960s or 1970s. So why we constantly use formal verification to save the world, to secure the world? Why there are still not many bugs in the software industry? I think this is a more interesting question, right? So first of all, formal verification is not magic, and there's no such thing called kind of like a silver bullet. I scanned the question. Well, I said, well, there's no such thing called silver bullet that can kill all those bugs and so on. And also, there are some root limitation of formal verification. So here I can even extend the question even further. So there are two kinds of formal verification techniques. So the first is what we call algorithmic verification. The meaning of it is we try to design some general algorithm or some general solver that to prove the correctness of the code or to verify the code. So that is the first approach called algorithmic verification. And you can see that the packed is along this line. Try to use some SMT solver, right, to prove the correctness of or prove some properties of the code. So this is the first approach, and this has a big limitation because what if the specification is simply that this smart contract or this code will terminate? This reduces this algorithmic verification into the famous halting problem. In 1936, Alan Turing has already proved that such general algorithm can't exist. So you can see there's a root limitation of the first approach. And then, while people think maybe we can go to another approach, which is called deductive verification. That is, well, we try to design a math systems and then use this math system to reason about a given program. And well, during this procedure, we may not have a general algorithm, but well, we rely on human intelligence to reason about those programs. And again, there is a root limitation of the second approach. Gödel in 1931 proved the incompleteness theorem, meaning that there are some truths for any consistent math systems. There must be some truths that you can't prove. So you can see that, well, there, in whatever approach you adopt, there must be something that is true, but you can't prove. So that's the first, the root limitation of formal verification. Second, the formal verification is difficult because you want to prove the code satisfy the specification. You want to prove these two models are equivalent, and sometimes these models' execution complexity may grow exponentially. For example, for the concurrent reasoning, for let's say quantum computing programs reasoning. So it's really difficult to do the proof. That's why we can't simply apply these techniques to solve all the verification issue. But let's see, for smart contract verification, well, as I said, well, it actually is a much simpler execution model. So Certik can handle almost all of this smart contract verification, and we already provide services for many of these big players in the domain. So I highly suggest that, well, all these smart contract projects, even all the blockchain projects should come to us for the verification or the auditing service. That's it.
You split it very, very well, Professor. Just deductive verification, algorithmic verification. But Stuart, do you have a response regarding the limitations of just algorithmic verification that Professor mentioned?
I'm not clear how the halting problem applies to PACT, because PACT forbids, it's not just Turing incomplete, it actually forbids recursion. So all PACT programs, in fact, before we even submit them for model verification, the first thing we do is inline everything in them. So I'm not concluding, therefore, that the halting problem doesn't apply, but it's not immediately clear to me why it would, given that we know at the outset that all PACT programs terminate.
Right. It's a good point.
Yeah, so halting problem is kind of like just one instance of the undecidable problem. So in the verification, some property reasoning, there are many undecidable problems. So kind of like, but definitely I didn't look deep into the packed language design, but I would say that, well, the verification in general, well, there are many undecidable issues there.
One thing that PACT does, just to kind of illustrate that a little, is we do leverage some of the models that are available in the Z3 prover. Like they have a model for real numbers, they have a model for lists, so they have, and so the one nice thing about PACT is that PACT, being kind of purpose built around particular kinds of workloads and use cases, the vast majority of those find almost direct expression in what is built in with Z3. And one of the reasons why this is good is that, in addition to whatever theoretical or kind of problems that arise by construction of what you're trying to specify, there's also performance issues that certain trying to prove certain things, even if you know they're going to terminate, will just take forever. And that's one of the great things about Z3 in particular is that it's really, really fast. So that, at least for the kinds of models that we're throwing at it. So this is something, and one of the things we tried very hard to do with PACT formal verification is to, PACT itself is a very opinionated language. And in terms of, it has an idea of how to do things correctly. And it has an idea of what you should and shouldn't do. And we've tried to extend that into the model language that is used inside of the code. And it's important to note that you can write models in PACT and then just get the code that goes into Z3 and write further models yourself directly in Z3. But the main thing we want to do is be able to give the developer the tools to say something very simple like, the balance of my account can never go below 0. You can never spend $1 twice. To give a DSL over these things so that common concerns in smart contracts can be easily expressed and verified, and the correctness of the code can be verified without a doubt for things that we all know we don't want smart contracts to do. So that's something, I think that's probably we're at the very beginning of some of this stuff, and I think it's one of the exciting things about PACT is that I think we're some of the first people to try to write a kind of formal verification for the common programmer by stylizing some of these things a little, because normally it's very, very difficult. I mean, it's not very difficult. It's just you have to be very learned to start directly taking these things on. So I think the efforts of Certik and the efforts of PACT are very harmonious here, in the sense that we're trying to get these tools out to the public, trying to get people to use these things.
Yeah, great, Stuart. Just staying on the topic of just PACT and languages in general. This is a question from our good friend at Crypto Marvel, and he asks to the professor, in the deep C formal verification language, how does smart labeling work? Can you share any technical details?
Okay, so the thing is, actually, DeepC does not. DeepC and smart labeling are two orthogonal techniques. So I can explain a little bit. So smart labeling is one of our technique developed to try to guess the specification of the program, because as I said, well, you need a program And then you need a specification and a formal verification. Try to prove these two things are equivalent, right? But the thing is, for average developers, they may get trained to write programs, but kind of like only limited number of them get trained to write a specification, and maybe many of them didn't know what is specification and how to write specification. So smart labeling is a technique we try to reduce the efforts of average developers. We try to get rid of the burden for them to write specification. And smart labeling, actually it's not that I would say not that magical, in the sense that we have a big database about the verified code. So we kind of like a key idea with we compare your code with our database and try to guess what is the specification for your program. But you can see that, well, the specification generated by smart labeling, it utilizes the information of your code. So again, you still need the human experts or still need the developers to check the generated specification to see if it indeed reflects your intention. So that's the smart labeling. So DeepC is a different effort. We try to introduce a new functional programming language to write not only smart contract, but also in general system software. And it can help you write the specification together with the code, and also generate proof obligations into Calc. And then some of them can be proved automatically. For some of them, if it can't be proved, then it will generate a proof goal. You can fill in the proofs by yourselves. So that's the DeepC project.
Yeah, it's good. One small note that I'm making, professor, is that you don't believe in magic. You said smart labeling is not magic, formal verification is not magic. But I want to make a small pivot. It's a very hot topic in our Discord. So at Privopunk asks, is it possible for formal verification to be made a standard for crypto exchanges as well for more security? A lot of problems and scams could be avoided if each project listing on exchange undergoes a formal verification check. Can a partnership on that level work? So I want to start with Stuart for this one.
Yeah, that's a great question. And it's people are probably familiar with things like ERC20, ERC721, and these are the interfaces that are used by exchanges to access tokens and things like that on Ethereum. So as such, they are very important interop standards. One of the things we're spearheading here at Kadena is an effort to write the equivalent interfaces in Pact, but to actually attach the formal verification proofs onto the operations so that you can easily verify that some token out there doesn't have a double spend bug. Like, you don't have to trust them to say, well, gee, did they actually use formal verification tools and tests and all that kind of thing? The idea being that the interface itself specifies a number of models that cannot be violated for something to be used on an exchange or something like that. So one of the ways that exchanges can embrace this is to start demanding is, one, when they onboard a new token or a new blockchain or something like that, that they inquire and have some kind of way to score a particular asset on the blockchain by how well the code was written and whether or not formal verification was used. Our vision is to have it that all assets that are traded on exchanges meet some minimum standard. And that's something we're going to roll out a community process surrounding our token interfaces, and that's something we're going to be kicking out in the upcoming months. So people should definitely keep their eye out for that. And that's for what we call fungible token, which is our version of ERC20, and non-fungible token, that's our version of ERC721. And again, the idea there is to have things like, you can't have a negative balance, you can't have, somebody can't spend a token twice, have things like that actually specified in the interface so that you can trade with confidence in these particular tokens.
Yeah, I agree. It's almost getting to the point where if you do see a double spend bug in happening in any of these projects, like, well, you should have used formal verification. Like it's almost a given that they didn't use it at that point. Professor, do you have anything to add?
Yeah, so I totally agree with Stuart. And so also I will share some facts that first of all, there are some good news that many big exchanges have already embraced the formal verification techniques. And Certik has already partnered with many big exchanges, including Binance, including Huobi and OK. And actually, most of these major exchanges, we already partner with them and provide the formal verification services for them. And but there are still some bad news. Again, it's not magic, and we can't avoid all the bad things happen. So first of all, for those let's say our clients, we only verified the security property of the smart contracts. Basically means that, well, for example, it will not be hacked by the hacker and so on. But again, when we prove correctness, we prove that, well, the code satisfies the designer's intention. But what if the designer's intention is not entirely good? So we can't avoid that. And it's more like the designer's design. Like, well, they want to be able to kind of like create more tokens than they claimed in the white paper. Well, nowadays we trying to send alerts of this kind of mismatch, but we can't say is incorrect contract. So we will send out all these alerts to the exchange and let the exchange to decide whether or not to list those tokens. So we can do some help, but in the end, well, there are still some factors that we can't control. This is one bad news. The second bad news is, well, most of the exchanges, they already require that the token get listed, need to have a auditing or verification report, and many of them are collaborated with us. But they can't say that, well, they only accept Certik's report. Well, because of some commercial reason, and so in that case, there are many companies, as far as I know, out there that they provide the so-called auditing report or verification report, but actually didn't do much verification or didn't do real auditing. So I would say these also introduce some potential risk, also leave some potential risk in the domain. So hopefully these can be improved in the next few months and in the next few years. That's it.
Yeah, sounds exciting. You mentioned big exchanges are already implementing formal verification, but I noticed you didn't drop any names, so maybe we could talk
Oh, no,
offline about who's dropping first.
he said Binance, Wobi.
Yeah, I said Binance,
A couple,
Huobi,
but
yeah, a
he
couple,
said
yeah.
a couple. He gives a little taste, but we'll see. Uh, so our good friend Miner Wizard. So how many different aspects of a project's code can formal verification actually target? As you said, is not a blanket solution, and you have to know what you're looking for in some sense. So let's start with Professor.
Oh, you mean kind of like what aspects of the project we will verify?
Yes.
Yeah, so yeah, I already mentioned a little bit. So first of all, definitely want to kind of like making sure that you are, as I said, I always mention the specification thing is because, as I said, formal verification is not magic. It's something like, well, you use these techniques and solve all the problems. And formal verification, we're trying to verify the correctness, right, or the security of the code. But what is the definition of the correctness, right? Uh, Now the kind of definition of correctness depends on, as I said, the designer's intention. So in most cases we prove that the code indeed satisfy the designer's intention, and then we also do some actual things like we try to verify that the designer's intention make sense. Like, well, your intention will not lead to, for example, the token stolen, and your intention indeed match, let's say, your white paper and your claims, and something like this. So that's the aspects of the project that we verify at the moment.
And Stuart, what do you think of how formal verification and just the different aspects of a project's code? Like, where else can we implement?
I mean, one of the things we've really shot or going for with Pact is covering the entire language with, well, one, just making sure that the entire language is covered in the formal verification tooling, but also, an example of something that you can do very easily in Pacts that's hard to do safely in other languages is a multi-step computation. Pact uses a construct called a def pact, which is a coroutine. And the nice thing about the coroutine structure is that it creates this linear sequencing from one step to the next. So it's very useful for things like, a kind of escrow procedure or something like that. And that's an example where I think the focus on the shape of the language and what the language is trying to do is very helpful, because by giving somebody a tool like this, the def pact tool, to basically write a simple piece of logic that says that after A comes B, after B comes C, allows us to also write corresponding models that have those concepts baked into them, such that one of the things that we want to test is that in between those steps, could anything happen to the database that would invalidate any of the logic that we find in this procedures? So in other words, if you have a program that in step one, expects to find a certain amount of money in someone's account but is only found out in step two, that's the kind of thing that could easily, the database in between those steps, because these steps don't happen one right after another, they're different transactions on a blockchain, that person could withdraw all their money out of their account in between 1 and 2. So if there's some kind of guarantee in 1 where they checked that user's balance and said, oh, sure, no problem, they've got the money right now, but then step 2 comes along and that's when they actually pay, that's the kind of thing that we can automatically detect without even having the user issue a specification for that kind of thing. So again, I think DSLs in general represent, for things like blockchain, represent kind of the best way to go. And Pact in truth is a DSL. It's something that is designed to make it very easy to write safe transactions, and in this case, transactions that proceed through multiple steps, interacting with some kind of data store. So when you use something like Pact, you have a fighting chance of covering your entire program and all of your business logic under formal verification. But as the professor said, there's no magic bullet. If a programmer doesn't write the formal the model, there's nothing you can do about that. And to a certain extent, you do have to the best thing we can do there is make sure that's one of the reasons why we have the models right next to the code, and why Pact has the source code actually on the blockchain that runs, so that you don't have to just read some audit report. You can go onto the blockchain and read the smart contract code yourself, and you can see the kind of things the invariants that they're testing. So it's not, you don't have to just blindly trust, oh, well, some auditing firm said these people are good, they must be good. You can actually go and even run these tests yourself.
So just
Yeah, I think I can maybe add a few more sentences if it's okay.
Yeah, go for it, Professor.
Yeah, so Stuart also mentioned that if you don't have the model, if you don't write the model, if you don't write specification, there's really not that much we can do, right? So that's why Certik introduced this so-called smart labeling, that we try to guess the model, we try to guess the specification, and it means that even if you don't write any model, I can still have something to check, but then it's definitely not as strong as the specification or model written by yourself. And I can share some story that why at the beginning we introduced the smart labeling, because when we audit some of our when we audit some code, we find that, well, last year there are many projects trying to kind of like create a ERC20 token, try to create some smart contract, but actually they they learn from other projects, they directly fork other projects, but they don't want to say, well, they didn't make any changes, so they still make some changes and claim that, well, it's done by themselves, and then ask us to do the verification. We find that, well, they make several changes and then introduce bugs. So it means that actually we can many codes out there in the blockchain world, especially last year. I would say this year is getting much better. Our code are similar, so we can. That's why we can guess the model. We can guess the specification, and that is also why we started the smart labeling. But nowadays, smart labeling is much powerful than the beginning design.
Yeah, it makes sense. I mean, both of you just brought up the point of just business logic and just logic in general. Does it make sense? Did the developers put formal verification in their programming language or just smart contract language in general? This is just a more controversial pivot. Is formal verification overkill? What is the benefit of formal verification over other types of testing? For example, brute force unit tests and just unit testing in general. Stuart, I'll start with you on this one.
Sorry, what's the question?
So is full formal verification overkill? What's the benefit of other types of testing like brute force unit testing in general?
I don't think it's ever. It doesn't have the same problems that unit testing you can definitely overdo. So we've heard of these things of like too much coverage, where developers kind of like try to, go for the green bar and try to cover every single line of code, and it being kind of overkill and making code hard to maintain. I would be surprised. Let's put it this way: I've yet to see an overly formally verified anything. I think things are under verified, by and large. So, and developers are certainly much more comfortable with things like unit tests. I mean, I think one of the things that is a bit of a leap is that these developers are going to be using tools that they don't fully understand. And I think that's something that's going to change over time, as I've discussed on our podcast a week ago or 2 weeks ago, that at one point it would have been completely unrealistic to expect kind of advanced developers to understand the nitty-gritty of something like TCP/IP, but now it's so ubiquitous that like if you've been programming for like 10 or 15 years, it's and you don't understand the low levels of TCP/IP and you've been doing network programming, that's pretty ridiculous, even though it's a complicated thing to understand. And likewise, I think as these tools kind of get increased use, people will start being able to buy into them more, because they will because it does, I think, to the uninitiated, it does sound like fairy dust, magic. Like, oh, the computer is just going to find every problem and you can trust it. BS. I'm going to write my and unit tests again are still helpful to developers. Now, I think probably someday, if these tools really get that usable, we would get to a point where every IDE and every SDK has, just like SDKs today often do have support for things like find bugs and static analysis tools, and those things can be extremely helpful and lead to very big improvements in code. What we'd like to see, and and what the Pact SDK I think is a preview of, or is making it real today, really, is the idea that like as you're writing your code, every time you enter in a new character, you're rerunning the formal verification system, and you're seeing invariants succeed or fail as you go, so that you could write code where you write the specification first, kind of like test-driven development with unit tests, but here you're doing it with a specification, so that you write the specification, it's all failing, and you start adding the bits of logic, and once the specification is happy, you're done. Another thing that I don't know if Certik has investigated as much is, and that we haven't looked at as much yet, is the fact that these theorem provers such as Z3 and Cook have interactive modes, and those things could actually get us to a future where you're actually having the computer write some of the code for you. I think that's future tech right now, but I think so. I look at it the opposite way. I think we should be using these tools more. I think eventually we're going to be in a situation where developers are very comfortable and familiar with these tools, and whole classes of bugs will be a thing of the past. That's at least what I would love to see.
Cool.
Yeah, Professor, again, it's full formal verification overkill.
Okay, so maybe I can answer. Yeah, so first of all, I totally agree with Stuart that I don't think it's overkill, and I would say it's under verified. So and the thing is kind of like you can imagine that unit tests are one. Also, you can view unit tests as a one kind of specification to your program, right? You design some test cases, you design the expected results of these test cases. You can view them as a part of the specification to the code that you just implemented, right? But the thing is, this specification does not cover all the cases, right? You didn't specify what is the next expected behavior. So that's a limitation of unit tests. I would say that, well, as Stuart said, that, well, once the formal verification has been more adapted by the mainstream software community, I would say maybe later unit tests can be replaced entirely by formal verification, because you can write a more accurate and a specification, and can cover all the possible cases. You don't need to kind of like enumerate all these test cases and expected values by writing the unit tests. So that's the first thing. Second, I would say may want to answer the questions raised by Stuart about the interactive model of COG. That's maybe in the future, the developer only need to write the specification, and then we can synthesize the program for the developers. And that's what Certik actually is doing. That is the Deep C programming language. Deep C programming language. Our key idea is we hopefully in the future with Deep C, the developers only need to write down the specification, and we will generate the code for you, and we will also generate the verification obligation, saying that the synthesized code indeed satisfy your given specification. But you can see it will be much harder than the verification itself. So it's still an ongoing work. Yeah, and hopefully once we have all these advanced tools, developers can these tools can benefit more developers. Yeah, that's it.
Yeah, Professor. So I want to elaborate a little bit. So the both of you have already started giving your vision of what the future of formal verification looks like. What are each of you immediately working on in your respective projects to bring about this future, magical future? So I'll start with you, Professor.
You mean, so are there anything I'm working on right now to along this way to the future, or
what are you working on that you're excited about for the future of formal verification with your clients with Certik?
Okay, so yeah, so I may kind of like talk in a broader way. So first of all, Deep C is definitely something we have spent lots of efforts, spent lots of time, and spent lots of money in, and we also get lots of support from IBM, from Ethereum, from Qtown, from many kind of like organizations in this project. And I already described that. So hopefully in the future, developers only need to write specification, and we can generate code for them and make sure the generated code, the synthesized code, are indeed correct. That reflects the specification or reflects the designer's intention. That is the first project we are working on. And the second project we're working on right now is we trying to verify the practical systems. and I can't say which one it is, but I would say it will generate a big impact to the industry, because we have already built many verified systems, but these systems haven't been really utilized well in the real industry. For example, CertiKOS, we built CertiKOS, which is the world's first verified concurrent OS kernel, but well, it's not being widely adopted, right, by the industry. So now we try to get a widely adopted system and verify that system. I would say it will also push forward a lot for the adoption of this formal verification techniques in the real world industry. Yeah, that's the second project we are working on. And the third project, and I will mention a little bit, that is people all knowing that the autonomous driving car is very popular, right? It's a big hot topic in these years, and there are some standard, right, set for the autonomous car, and right now people are working on the L4 autonomous car, but in order to commercialize it, you have to reach the higher level standard, which is called L5. If you read the L5 standard, you find that, well, in order to achieve L5, the key system, the control systems of the autonomous car has to be fully verified. So you can imagine that in the future, all these cars runs on the roads, their systems will be fully verified. I would say that will be the future of this technique.
The future autonomous driving, and just some interesting projects you listed there, Professor. And how about you, Stuart? What are next steps for PAC's formal verification?
Well, I'm really excited about what's coming out with PAC. We're always looking at things from the point of view of how can we make a smart contract developer's life easier? How can we make it that they can get their products out to market faster? And PAC 3.0 is going to be coming out in the next couple of weeks. And one of the things this introduces is some kind of exciting new models for managing secure, writing secure code that deals with ownership. And I'm not going to get too deeply into it right now, but the concepts are basically the notion of capabilities and guards. And capabilities, for one, is the idea that instead of relying on ambient security properties of your environment, that you reify all of your writes in your system as data types. And it just makes it much easier to write code that it isn't exposed to, like a classic example would be, you could write a smart contract that says, that writes a row in the database that says this user is authorized to do something, and then your code reads that once and then goes and does a whole bunch of stuff. And then if that ever gets cached in any way, then you've got code that's insecure, because maybe during that operation, that user should lose the right to be able to do something, because maybe it's been discovered that they're, or they have some kind of thing where they can only do it for a certain amount of time or use up a particular amount of a resource. So introducing abstractions to make these things much more tangible and easy to use for developers goes hand in hand with designing the right kind of metaphors in the model language, so that you can ensure that what you're trying to do with something like a capability or a def pact or some of these things we have like user guards, which by user guards are a way that in PACT you can do things like hash time locks, where something that's very difficult to code, the code to guarantee a safe hash time lock. This is what powers things like Lightning Network, where instead of using a public key, you can put a timeout and guard some resource with a secret represented by its hash. These are very powerful tools for cross-chain, for sharing resources cross-chain or doing escrows or things like that. But it's hard enough to write the code, and then you're going to have to turn around and try to rack your brain to figure out how you're going to try to express this in some formal verification regime. So instead, what we try to do with PACT is come up with ways, give you these things as kind of pre-baked items, and that come with a that come with the necessary logic in the model verification system, so that you can write code that uses some very powerful abstractions for ownership and custody, and then you can leverage our formal verification system to ensure that it's actually doing what you intend. So this is stuff coming out in Pack 3.0. Stay tuned. It'll be showing up on our servers and on our docs, and before the end of the month.
Awesome. So let's end with my favorite question, Professor. Where can we find you online? Plug your social channels, and where's the best place to learn more about Certik?
Okay, so good question. So I didn't spend much time online. So, but Certik, so we have a Telegram, and we will post all our updates on the Twitter, and we also have a website, and I think kind of like it contains lots of details, except for DeepSea, because DeepSea is still an ongoing research project, and we will release more details when we think it's ready. And well, that's it.
Great. Thank you, Professor. And then Stuart, how can we stay informed about news from Kadena, and where can we find you online?
Well, Kadena, of course, you can, right here on Discord, it's a great place to find out what we're up to. And there's our newsletter that comes out that we send out quite regularly that you can sign up for at kadena.io. I'm on Twitter with my lovely handle, Sir Lensalot. And we also have a lot of people on our team who are working on this stuff, such as Emily Pillmore, who I did our podcast with on formal verification a couple weeks ago. This is something we're always working on and thinking about, and we're also looking to collaborate with exciting companies like Certik, and so definitely stay in touch, and there's exciting things on the way.
For sure. A lot of exciting things from Certik and Kadena. Thank you once again, Professor, for taking the time to join us.
Okay,
And
thank you.
Stuart. Thank you, Stuart, for setting some time to join us as well. It's been
Okay,
a blast.
thanks.
Terrific. Thanks, everybody.
So
Yeah, thanks everyone.
Thanks, Miguel.
Before everyone heads off, just stick around and continue the conversation here in Discord. Any of the questions not answered today, we try our best to get you an answer. So just follow us on Twitter, Kadena_IO, and just stay alert, because we're doing more AMAs in the future, and for sure continue the conversation here on Discord. So thanks, everybody.